Good morning. My name is Jigdish. Today, in this session, we will study about the atomic structure of the matter. So, how many number of theories have been proposed to explain the atomic structure of the matter? Let us study today. In 1803, the John Dalton proposed a theory to explain the structure of the atom on the basis of the well-known facts or well-known laws. So, that is the law of conservation of a mass, law of conservation of chemical combinations, or law of definite proportions, and law of multiple proportions. By using these laws, the John Dalton proposed the atomic hypothesis, which consists of the following postulates. So first one is, we know that all the chemical elements are made up of extremely small particles, or all the matters are made up of extremely small particles called atoms. These atoms are very small, which we cannot further subdivided by any physical or chemical process. So that is the first postulate, which is given by the John Dalton. All the atoms of the same elements are identical. So it means that, for example, if we take the hydrogen, oxygens, or carbon, so in that molecule or in that atoms, all the atoms of the same element remains the same, or size or physical properties or chemical properties, all the things remain same. So that is that these two postulates were given by the John Dalton. So this is the first atomic model, which explains the atoms. So after these postulates, the John Dalton, he tried to calculate the water vapors, that is the how many number of molecules or the atoms are present in case of a water vapors, and after these proposals the Avogadro hypothesis, kinetic theory of gases, were also explained. But the exact atomic model was explained by the J.J. Thomson. J.J. Thomson performed the cathode ray tube experiment to find out the specific charge of the negatively charged particles. So he also found that negatively charged particles are nothing but the electrons. He found that the charge of the, what is the specific charge of the electron, and what is the mass of the electron? It is found to be 9.1 into 10 to the power of minus 31 kg. And what is the charge of the electron? So that is 1.602 into 10 to the power of minus 19 coulomb. So the exact value was not got by the J.J. Thomson, but after, by using the Millicon oil drop experiment, Stokes law for small drops, X-ray diffraction methods. So by using these methods we can find out the charge of the electrons. The J.J. Thomson, he proposed an atomic model, which consists of number of postulates. That is, an atom consists of positively charged particles and negatively charged particles. So here the atom consists of equal number of positively charged particles and the equal number of negatively charged particles in an atom. So it means that an atom is electrically neutral. So that is the first postulate given by the J.J. Thomson. And next one is, an atom consists of a positively charged sphere, with a negatively charged electrons are embedded in it. So it means that the Thomson atomic model also, it is compared with the watermelon. So he considered that the watermelon seeds are the negatively charged particles, the red part of the watermelon as positively charged particles. So it's why the J.J. Thomson model is also known as the plum pudding model. By using this Thomson atomic model, we can explain, that is only the structure of the atoms, how it was. But it failed to explain the stability of the atom. So how the positive charges holds the electrons in an atom. And the major drawback of the Thomson atomic model was, it failed to explain the alpha ray scattering experiment which is performed by the Rutherford. So in this experiment, So he used the alpha rays, which are the positively charged particles, and it penetrated through the gold foil, and he got a picture of that. Some of the rays are deviated and some of the rays are transferred without any deviation, and only few of them are repelled back or reflected back, so into 180-degree direction. So by using the Thomson atomic model, it was not possible to explain the experiment. At that time, the Rutherford, so he proposed a Rutherford atomic model. By using the alpha ray scattering experiment, the Rutherford has given some postulates. The first one is the entire mass of the atom is concentrated at the center. That is called as nucleus. The nucleus is positively charged. The electrons are negatively charged, which is revolving around the nucleus in a circular orbit. So there is electrostatic force of attraction between the nucleus and the electron, which is provided by the centripetal force. So these three concepts were explained by the Rutherford. But still he failed to explain the stability of the atom. According to Maxwell's electromagnetic theory, any accelerated charged particles emits the electromagnetic radiation. So here the electron is a charged particle. It must emit the electromagnetic radiations while moving around the nucleus. So it means that while emitting the electromagnetic radiation, it must lose its energy. So finally or ultimately these electrons would collapse into the nucleus. Then it failed to explain the stability of the atom. And also the Rutherford atomic model failed to explain the arrangement of the electrons in an atom. To explain these two concepts, in 1912, the Niels Bohr proposed the Bohr's atomic model. So this Rutherford atomic model difficulties were overcome by the Bohr's atomic model by introducing number of concepts. The first one is the Bohr has introduced the concept of stationary orbits. The electrons cannot revolve around the nucleus in a circular orbit in all possible orbits, but it can revolve only in certain discrete orbits, so which are prescribed by the quantum conditions. So these orbits are called stationary orbits. These orbits are called the stationary orbits. This is the first postulate. Second one is, in stationary orbits, the angular momentum of the electron is quantized. The electron is not present in all the orbits. It is present only in those orbits which is satisfied by this condition. That is, the angular momentum of the electron is quantized. So it means that the angular momentum of the electron is the integral multiple of h by 2 pi, where h is a constant. So if we take for n number of orbits, so it is nh by 2 pi, where n is equal to 1, 2, 3 and so on. That is the number of orbits. So this is called the Bohr's quantization rule. This is the second postulate. So whenever the energy is supplied to an atom, so in that case the electrons are moves from the ground state to higher energy state. So when the electron jumps from lower energy level to higher energy level, so once again it comes back to the ground state. While coming back to the ground state, it emits the electromagnetic radiation. So which is given by E2 minus E1 is equal to h mu. So where h mu is the energy of each photon, that is E2 is energy of the higher energy level, E1 is energy of ground state or lower energy level. E2 minus E1 is equal to h mu. So this condition is called the Bohr's frequency condition. By using the Bohr's atomic model, so we can explain the radius of the orbit, velocity of the electrons which is revolving around the nucleus in a circular orbit. So we can calculate the energy of the electrons in nth orbit, and also we can get expression for the frequency of emitted spectral line. So we can calculate the Rydberg constant, we can calculate the wave number, we can calculate and we can explain the spectral series of the hydrogen spectrum, so which consists of Lyman series, Balmer series, Paskin, Brackett, Fund series. And also, so we can draw the energy level diagram. By using the Bohr's atomic model, so we can explain everything of the atomic structure. What are the drawbacks of the Bohr's atomic model? The Bohr's theory could not explain the fine structure of the spectral series or spectral lines. What does fine structure means? So in any Lyman, Balmer, Paskin series, so for example, if you take a Balmer series, it consists of H alpha, H beta and H gamma lines. Each line consists of number of components. So it is not only one line, it consists of number of lines. So this is called as a fine structure of the spectral lines. But the Bohr's theory could not explain the fine structure of the spectral lines. And second drawback is it failed to explain the relative intensities of the emitted spectral lines. Now, to overcome this difficulty, this Sommerfeld, he proposed one relativistic Sommerfeld atomic model. So in the Sommerfeld theory, the Sommerfeld explained, in the Sommerfeld theory, he introduced the two main modifications. First point is, the first correction is, the path of the electron around the nucleus is an ellipse. The Sommerfeld theory has introduced the two main modifications. The first one is, the electron is revolving around the nucleus is not in a circular orbit. Instead of that, it is revolving around the nucleus in elliptical orbit. The path of the electron around the nucleus is an ellipse with the nucleus at one of its foci. The circular orbits of the Bohrs are the special case of this elliptical orbit. The second one is the velocity of the electron moving in an elliptical orbit varies at different parts of the orbit. So which causes the relativistic variations of the mass of the moving electron. The velocity of moving electron is not a constant, it varies at different points of the elliptical orbit. Sometimes it moves faster, sometimes it moves slower, but it is not a constant value. So that's why he introduced, to explain this concept, he introduced the relativistic concepts. The variation of mass can be explained by using the special theory of relativity, that is m is equal to m naught by root of 1 minus v square by c square. So he introduced the concept of relativistic mass. To explain this Sommerfeld atomic model, so he introduced the two more variables or the two quantum numbers, that is a principal quantum number and azimuthal quantum number. The principal quantum number, so which determines the energy of the electrons, and azimuthal quantum number, so which determines the orbital angular momentum of the electron. So he introduced these two azimuthal quantum number and principal quantum number to explain this concept, and he succeeded. And there is some of the drawbacks of this Sommerfeld atomic models also. It could not explain the distributions and arrangement of the electrons in atoms. The Sommerfeld atomic model, it failed to explain the spectra of the alkali metals. Spectra of alkali metals like sodium, potassium, etc. And the Sommerfeld atomic model, it could not predict the correct number of the observed fine structure of these lines. This model, it does not give any explanation to the intensities of the spectral lines. So that's why this Sommerfeld atomic model also needs correction. So now, we have studied about the Dalton atomic model, Rutherford atomic model, Bohr's atomic model, Sommerfeld atomic. In the next session, we will study about the vector atomic model, which is a continuation of this. Thank you all.